Hello, I am Dr. M. Gangappa, Faculty of CSC, AML, IoT and RAI Department. Today I am going to discuss one of the topic in Automata and Compiler Design. So topic name is YACC Program for Expression Validation. So this is one of the important topic for the second BTech students. Let us see how to write a YACC program and how to run that program in the Linux environment. Shall we start? So what is YACC? YACC is a parser generator tool. You know what is parser? Parser is used to check the statement is grammatically correct or not in a compiler, right? So in order to implement the parser, we use one of the tool called YACC, yet another compiler. Actually, it implements the one of the parser. Parsers are of two types. One is top-down parser, second one is bottom-up parser. In that, it is used to implement the bottom-up parser. And that bottom-up parser, the parser it implements LALR 1 bottom-up parser. So let us see how to write and what is the format of YACC program and all to implement the parser. So these are the main steps involved in the YACC program. So that is how YACC works. So first what should we do here is we should write the YACC program. After writing the YACC program, then we should save that program with the extension .y. So after that we should compile the YACC program using the YACC compiler so that it would generate the output, three different outputs. One is y.tab.h, y.tab.c, y.output. So in that, one of the important file that is being generated by the YACC compiler is y.tab.c. This is a C program has been generated here. So once the C program has been generated, that is saved in the C file. C file name here is y.tab.c. So once we get the y.tab.c, then we should compile that C program by using the C compiler. So C compiler will compile the y.tab.c file. So once it is compiled, then it would generate one file. It would generate the output as object code. So object code is generally saved in the a.out file. This is the standard file name. So whenever we get the object file in the file name a.out, then we should run that object file by providing the input, and so that we can generate the abstract syntax tree as the output, right? So let us see how to write YACC program. So YACC file or program consists of the following sections. It is quite similar to the C program, but little variations happen here. Let us see that one as well. First section in the YACC file is declaration section. So this is quite similar to the declaration in the C programming as well. So followed by the declaration section, YACC file also contains one more section, that is the grammar rule section. So this grammar rule section is the heart of the YACC file because this grammar is being used to verify whether the statement, input statement is valid or invalid. So that's why grammar is very much important. So once the grammar rule sections is done, then last section is the auxiliary procedure section or additional C code section. So these are the three important sections. Once again, let us see. First section name is declaration section. Second section name is grammar rule section. This is one of the important section in the YACC program, that is grammar rule section. After that, additional C code section. So these are the three important sections we need to write or we need to follow while writing the YSSC program. So after, let us see the sections one by one. In the declaration section or definition section, the code can be seen like this. So first, what should we do here is, we should write the code by using the sample code, such as percentage symbol followed by open curly bracket. After that, we should declare the header files that are required to our program. For example, hash include stdio.h is the header file. That header file is required to perform the input and output operations. Similarly, one more header file here I have taken is hash include std lib.h. This is the library file. So this is required when we use some kind of functions like exit and all. After that, we need to go with one more symbol, that is percentage symbol followed by close curly bracket. So after that, we need to declare the tokens that are required to perform the operation. So here tokens are in the arithmetic expressions. Generally, tokens can be number and identifier. Already we know that the arithmetic expression. Let us take one sample example. Arithmetic expression can be seen like this. For example, expression can be seen like this: 2 plus 3 star a. This is the arithmetic expression. So in that arithmetic expression, when we observe this, we can identify one thing, that is 2. 2 is a number. This is a number. And 3 is one more number or a digit. And a is one ID. A is an identifier. And plus and star are operators, right? So this is the expression, general expression format. Therefore, what should we do here is, we should take the number as well as ID from the lex tool. Because number is one token as well as ID is also one token. So that what should we do here is, we need to declare the tokens in the declaration section of the YSSC program as percentage. This is percentage ID followed by number, because we need number as well as ID. So this is how we can write the code in the declaration section in the YSSC program. This is quite easy to understand. Next one is rule section. This is the second section. This is one of the important section. This section is heart of the YSSC program. In the rule section, what we should do here is, we should insert the grammar that is being used to verify the input statement is valid or invalid. So grammar rule section is very important one. So here I am taking the arithmetic grammar. Arithmetic grammar can be used to perform the arithmetic operations. So arithmetic grammar generally can be seen like this. E gives E plus T by T. T gives T star F by F. F gives open parenthesis capital E, close parenthesis, or ID or number. This is one grammar we should remember. By using this grammar, we can perform the we can verify the arithmetic expressions. To verify the arithmetic expression, this is the grammar to verify arithmetic expression. Arithmetic expression, whether the arithmetic expression follows this grammar rules or not. This is the important one we should remember. So in this, this is actually the grammar. This is actually the grammar scene. So we should take this grammar in the rule section as expression followed by colon. Colon is indicated by the arrow mark. Look at here. This is the colon. Colon is quite similar to arrow mark. Instead of arrow mark, we should use the colon. After that expression, after that plus. Plus is the token. Plus is a token. Therefore, whenever we get a token, in that case, we should use single quote followed by term. Term means T and or term. And this is one complete production, right? So whenever the complete production is finished, in that case, we should use a semicolon. So similarly, how can we insert the second production? Let us see. So in that second production, this is the second production, right? To insert the second production, first take the T means term, and instead of arrow mark, we should take colon. We should take colon. After that term, after that star. Star is a token. So whenever token happens, in that case, we should use single quote followed by factor and or symbol factor and semicolon. Semicolon, whenever we use semicolon, meaning that that production is ended here. Similarly, last production can be written like this. This is how we can write the grammar in the rules section of the YACC program. So once this is done, next section contains the additional expressions. Before going to see that, here we need to understand one more thing, that suppose you want to understand or you want to know the more information about the grammar symbols. In that case, we should go with the semantic rules. These are called the semantic rules. Semantic actions. So with the help of the semantic actions, we can understand what is happening in the each grammar symbol. Suppose this is one grammar symbol. What is there in that grammar symbol? This is one grammar symbol. This is one more grammar symbol, right? So this is one more grammar symbol. So this is the grammar symbol. This grammar symbol is generally EXPR is one grammar symbol. EXPR grammar symbol can be used to hold the resultant value of this expression EXPR plus term, right? So in order to represent this, we use the symbol $. $. Is a positional character in the line X. With the help of that, we can represent this. Similarly, this is the next non-terminal after the colon. So this is the first non-terminal EXPR. So first term. So first term can be represented by $1 followed by plus. Plus is a terminal. So whenever terminal happens, the terminal can be taken as it is. This is taken as it is. Next one is the term. Term is a non-terminal. So whenever non-terminal happens, that non-terminal can be represented by the positional characters. That is 3. So 1, 2, 3. So this is third position. So similarly, this is the R symbol. R symbol means next alternative production for the EXPR. EXPR gives term. This is the meaning of that one. So this can be represented $$ equal to $1. So similarly, we can write the semantic rules for this production as well as this production. For this production, here I am going to read it out. $$ equal to $1. $1 indicates the term, and star is star, and factor is indicated by $3. And this factor is indicated by $1 because this is the or symbol. Or means this term can take either this production or this production. So similarly, next production can be represented by the semantic rules as $$ equal to $1. Now let us understand some more important declarations. One is percentage right. Percentage right is one kind of term or keyword, percentage rate. So this term or keyword in YACC is used to declare the operator associativity. Suppose operator is right associative, in that case we use percentage right. Suppose operator is left associative, in that case we use percentage left. Suppose operator is no ASOC, non-associative, in that case we use non-ASOC. For example, cap. Cap is the one operator. This operator generally performs the operations from right to left. Therefore, this can be represented as percentage, right? For example, plus is the operator that can operate from left to right order. So therefore this can be declared as percentage left followed by plus. Like this we can use some keywords in the declaration section as well. So these are the some of the books, two important books you can refer to get the more information in writing the YACC program. Now I am going to take one sample example to explain how it works. So this is the sample program. In this sample program, what I am trying to do here is, here I am going to write one YACC program to test the validity of one simple expression. Example, let us take one simple example for the arithmetic expression or simple expression. Example of expression is 2 plus 3 star a. Whether this is correct expression or wrong expression. So generally expression, when we see the expression, we can understand that in that expression involves operators and operands. So this is the operand, operator, operand. Is it right? For example, 2 plus 3. So this is one expression. This is one expression. Expression can be represented operator, operand, operator, operand. Expression, right? Suppose the entire expression, I mean complex expression, follows the operand, operator, operand formula or not. So to check that, we need one grammar. So that grammar is expression grammar or arithmetic grammar. Using that arithmetic grammar, we can verify it. So to write the program, YACC program, to test the validity of the simple expression, what should we do here is, first we need to understand one thing, that what is required to write the YACC program. So if we consider this as an input, in that case, let us observe what is required to write the program based on the input. So first requirement is number. Second one is, this is also number, and this is identifier. So what should we do here is, first we need to have number and identifier. So in the arithmetic expression, when we observe the arithmetic expression, for example, E gives C plus T by T, in that case we can get only the non-terminals operate terminals and non-terminals, right? So but we don't have the number and ID here. So for the grammar, what should we do here is, we need to supply ID as well as number. So first we need to supply ID as well as number to the grammar, then only that grammar is meaningful, right? So that's why first we need to take one thing, that first we need to write a program to identify the number as well as identifier. So we will identify that, scanner only will identify whether this is a number or whether this is an identifier, right? Therefore we need to write a scanner program. Scanner program is also known as legs program. Scanner only can understand numbers and identifiers, right? So legs program can be should be written here. So that is the first step, that is step number 1. So now I am going to explain step number 1. Step number 1, in that step number 1, we should write the legs program to recognize the number as well as identifier. So in that legs program, first step is declaration section. In the declaration section, percentage open curly bracket, this is percentage open curly bracket. After that, hash include y dot tab dot h. So y dot tab dot h is required to link the YACC lex program to YACC, lex to YACC, lex program to YACC. To link this, we use y dot tab dot h header file and percentage close. This is the this is how we can close that declaration section, right? I'm going to close this. After that, this is the transition rule section. In the transition rule section, what should we do here is transition rule section should begin with percentage symbol followed by percentage symbol. After that, we should write the regular expression. This is the regular expression. This entire one is a regular expression to represent an identifier. So already we know that how to write a regular expression for the identifier. So generally identifier in our C programming language as letter followed by letter or digit whole star, right? Letter followed by letter or digit whole star, meaning that first character must be the letter, followed by second character onwards. It can be either letter or digit. The same thing can be expressed in this way, right? Letter can be A to Z or A to Z, and or A to Z or capital A to Z or 0 to 9. This is the letter and this is the digit, whole star, right? So after writing the regular expression, this is regular expression for the identifier, then this is the code for returning that ID. Similarly, one more is required, that is number. To write the number can be 1 2 3 is a number, right? So 1 is a digit, 2 is a digit, 3 is a digit. So therefore digit can be represented by 0 to 9. So how many times 0 to 9 should happen? 0 to 9 should happen more than one time. 0 to 9 should happen more than one time in 0 to 9 whole plus is the regular expression format. So this is the regular expression format to represent the number. Already we know that. After that, dot is a symbol used in the regular expression to indicate, this is very important one, to indicate any single character. This is used to indicate any single character. For example, 2 plus a. 2 is a 2 can be recognized by the number, and a can be recognized by ID. But how plus can be recognized? So plus is a one character, single character, right? So this in order to recognize this single character, we use dot, right? And the next one is generally after entering the input to the program at the prompt, what should we do? We should press enter. So in order to indicate that enter, we use new line character. So whenever new line character happens, it should return the value 0 to the YACC program. So this is how we can write the program, lex program, to recognize identifier as well as the number. So that is the first step. So once the first step, let us see the program, how to write the first program. So 1 minute, I'll show you how to write it. So first program is lex program. I'll show you that lex program. VI space program 1.l. This is the first program, right? Just already I have explained this program. This is the first program. Just now I have explained. So after writing this program, how to save this program? To save this program, we should use escape. I'll write that. To save this program, save and quit, we use the command save and exit command. Save and exit. After writing the program, we should save that program and we should exit from that program. For that, we use the command escape plus shift colon type WQ. So let us do that. So escape shift colon WQ. Escape shift colon WQ. After typing WQ, then we should press enter so that we can come to the prompt. So once we get the prompt, we should run this program. Sorry, we should compile this program by using the command. I will write the command here. To compile the program, compile this program, we use the command legs space program.l, program1.l. So let us type this legs space program1.l. So this is compiled. Similarly, we should go to the next program, that is YACC program. I will explain that YACC program. This is the step number 2. Step number 2, we should write the YACC program. So in the YACC program, already I explained there are 3 sections. One is declaration section, YACC action rules section, and last section is the procedure section, right? In the declaration section, we can declare the header files as well as tokens. So header file that is required for our program is stdio.h, and tokens that are required to perform to validate our arithmetic expression is number and ID. For example, 2 plus 3 star. In that case, we have a number, we have an ID, right? Num and ID. These num and ID are taken from the legs program, and actually grammar involves some operators like plus and star. So plus is left associative. Already we know that left associative and right associative. Meaning that it operates the expression from left to right order. And next one is star and division. These are also left associative operators. So this is how we can declare the variables, right? So after that, grammar rules section. This is a grammar rule section or YACC action section. So in that action section, we need to take grammar. So here grammar considered is E gives E plus E, or E star E, or E minus E. Okay, or E division E, or E expression E, or E number, or ID, semicolon. This is only one production. So this can be expressed like this. First one can be expressed like this. Second production, third production, I mean E production, fourth alternative for the E production, fifth alternative, sixth alternative, seventh, and complete one is whenever this entire production is done, then we need to use semicolon, right? This is how we can write the grammar. So once the grammar is written here, then we should close that one by using the percentage. So after that, we should go to the main program. So integer main, already you know that printf statement, using that we can print the print something else on the screen, that is enter an expression. After that, YY parse. This is very important one. By using this, you can scan the input. Scan the input. After that, if this scanned input is scanned, that input is passed to the rule section, I mean YACC action section. This YACC action section will internally try to verify the input. If that input follows this grammar, if that input supplied follows this grammar, then immediately the next statement will be executed. That is expression is valid. Suppose the input entered doesn't follow. In that case, it goes to the error section. Error section. Doesn't follow means error section. Doesn't follow. In that case, it goes to the error section. In that error section, we are going to print the statement is invalid, right? Let us see this by taking by using the code. So program for this is vi space program 1.y. This is the YACC program. Already I have explained this one. So first one is declaration section. After that, this is how you can declare number and ID as a tokens, and plus and minus are left associative. And similarly, this is the grammar. Already I have explained how to write the grammar in the grammar rule section. This is the main program, and the YY parse is very important one. This function will scan the input supplied by the user, and after that it will send that um, input to the rule section. Rule section will verify that input, whether that input follows the rules or not. Suppose input doesn't follow, in that case it will throw the error. So that error is collected here, void YY error. So in that case, if this function is executed, then we print the statement invalid expression. Otherwise, we print the valid section. Let us see this one. Similarly, so after that, let us compile this program. In order to compile this program, here I am going to write the code for the compile this program. To compile YACC program, we use the command YACC -d program 1.y. Program 1.y. So that whenever we do that, we get the one file called y.tab.c file. That is C file. Let us see this first. YACC -d program 1.y. So run this. So code has been compiled. Next one is after compiling this, we need to compile two C programs. Let us go with. So first C program is legs. So $legs program on data. So this generates one file called legs.yy.c. This is C file. C file. This generates one file called y.tab.c. This is C file. This is also C file. There are two C files. This is first C file. This is second C file. So what should we do here is we need to compile C files. C files. We use the command $cc space lex.yy.c space y.tab.c -o and x. So this is the command. Using that we can compile the C file so that we can collect the object code in the file called x. Let us see that. cc space y.lex.yy.c space y.tab.c space -o space x. Okay. So these are the warnings. No problem. We can run the code. To run the program, we use the command $/x. $/x. X is the object file. dot slash x. So here it asks us to enter the expression to verify it. So here I'm entering one expression, a plus 2 star 3. Now we are going to test it whether it is a valid expression or not. So a is an operand followed by operator, followed by operand, followed by operator, followed by operator. So everything is fine, therefore this is valid one. So according to this, when we observe this, so this is the valid expression, right? This is valid expression. Suppose you want to test it once again. Let us go with one more example. So 2 plus 3 20, sorry, 2a plus 3. 2a plus 3 means operand, 2 is an operand, a is an operand followed by operator, followed by operand. So let us see whether it is valid or invalid. So this is invalid obviously because operand followed by operator should happen, but here instead of that it happens operand followed by operator. So that's why it is invalid. So like this we can verify whether the statement is a valid statement or invalid statement. So the main purpose of parser is to verify the statement is grammatically correct or not, right? With this I can conclude my session. Thank you for watching my video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.